this is what we're going to do today. We're going to prepare a roof with this roof that we have already created. But now we have to prepare a roof with a thermal insulation. Then we need to prepare something to get rid of water. And finally, we will insert, it's not a window, this is a curtain wall, so that we can have light through this roof, natural light. At the same time, I will show you how to work with walls that don't have, okay, so we can work with the shape of these walls. They are not rectangular walls. We can do the same with curtain walls. As you can see, this curtain wall is adapted to the shape of that beam. And we can open windows on that wall, but always following the structural elements. So the structural elements in this kind of construction are the limits of our openings, of our windows or our curtain walls. Remember that we did this last time. We created that roof with that shape, working with the massing and modeling, or massing and site, sorry. Then we created parts, and we will do the same here we will end up creating different parts on that roof. So that will be the goal. Oh, and finally, for sure, we have to start preparing the documents, the technical documents. So we will create a section in this direction. And in this direction. So in section 2. So there are a lot of things to solve here, because there will be the wall. We have the transition between this wall and that roof that we created here. So we have to work with this. And next week we will work with the callouts for these details. And on section 3, we will end up defining all these elements: this roof, this curtain wall, this gutter to get rid of water. Then we need a waterproof. So we will end up having a nice call out of these details here. And that's it. So we are going to start. Now, save, and I will open this one. Okay. This is where we finished on Tuesday. We have this roof here, but now we have to prepare the main roof, and we have to prepare this wall. We can start with the wall. As you can see, we have a wall that is not rectangular here, so we are working with different. We are filling this grid with our wall, and well, I'll show you how to do that. Maybe you know how to do it. Anyway, I'll show you how to do it. First, we need to go to level 24, because this is level 24, and we need to create this wall. We have already worked on level 0 with this kind of wall here, and well, we have to. This is what we did. We created layers, the thermal insulation, the concrete masonry units, more thermal insulation here. And then we have this steel plate outside. The thing is that we had to work with parts, and we need to okay, that's it. Here we have this covered by thermal insulation. So this is not a thermal bridge anymore. We have this exposed steel column. If we had it exposed to the inside, there will be a wonderful thermal bridge, and there will be a lot of issues. So we need to, even we can use, like in a real construction, we will use foam here. Okay, so before placing this layer of thermal insulation, we will work with foam. We will place foam here in this cavity, and then we will solve the thermal breach by adding more thermal insulation. We want this face, this exterior face, exposed. Okay. Maybe we will do that because we will have some plan detail, but today we're going to work with sections. So this is the idea. We need to create those walls, but now on level 24. So on level 24, but look at this. Now the beams or the columns, sorry, are in a different position. Okay, because we are working in this perpendicular direction. And well, does it matter? Yeah, it matters. Why not? It matters. But let's find out. First, I have to create a wall. So I created this basketball court wall 1, and this is the wall I'm going to use. And I'm going to start from this place to that place. We're not going to do this because I want this structure exposed. Okay, so we end the wall here, and we can start the wall there. And now, yeah, if this is the thermal insulation, we have to move this thermal insulation in this direction. So we can move slightly this here. Okay, so when we create parts, we can move the thermal insulation, and this layer will be hiding the structural element here. It will be exposed outside, but we won't see this element inside, and it will be, well, we will solve that thermal breach. Well, that's good to start. But now on the 3D view, well, we have to adjust this. I think it's unconnected. We can connect it to level 36. But, well, this is not what we want, because we want this beam to be exposed. And we want this wall to be adjusted to that shape. How can we do that? We can select the wall. We can move to this front elevation. And then I can use this edit profile. I can use these handles, the shape handles. Okay, I can use these shape handles, but it won't work for this tilted beam. Okay, so I think if we edit the profile, here we have this pink line, and we can move it. Move constraints. To make it more accurate, I always use, well, if I can't use align, make sure that you move it, yep, here. And now this one, we have to adjust it to this is the roof, and this is the beam. Okay, so we have to adjust this profile, move constraint, to the beam. Can I use align now? Yes, I think so. Yep. Now this pink line is on that beam, and we have to trim here and there. Okay, so this profile now is adjusted to the opening. If it's not a rectangle or it's not a square, we can do that, and yeah, it works. Can we do this with curtain walls? Yes, we can. And we're going to do that now. So if we select a curtain wall, this storefront, we're going to do it here. We go to level 24 again, and I can start here. And now I can finish here because the curtain wall will be within this steel structure. It's not affected by, so the curtain wall is thinner than that space, so I can place the curtain wall here. And then on the 3D view, we have this terrible thing, and now we can fix it. Unconnected to, or we can connect it to level 36. we can use the shape handles for the straight part, but for the tilted part, we have to edit profile, and then we have to adjust this to this beam and trim. Yep. And now we do have a curtain wall adjusted to that beam element. Okay, so this is the elevation, and I don't know, it's up to you. You have to design a nice elevation, but keeping in mind that this is a basketball court, so we have to be careful with light, because in this kind of sports facilities, we need natural light, but you can't practice a sport with the sunlight hitting on your eyes. Doesn't make any sense. That's why this part is always north oriented, because the north light is not bothering us, and we don't have light from the south. So that's the only criteria. We will open the windows in this side, and this has to be the north. We can change, because now I think this is east to west oriented. We will change the north at the end of the process. But now let's work with the roof. So how does it work? Well, this has a name. This kind of roof is the sawtooth roof. It's a sawtooth because, well, it's like a saw with this shape like this. But what is the advantages of this kind of roofs is that if we orient the opening to the north, we have a reflected diffused light that works well in sports facilities, in factories. We need people to focus on their work. So if we have sunlight, direct sunlight, that will affect our attention. So the best thing for this kind of sport facilities or factories is having a reflected diffused light from the north. So that's why we open this to the north. And then we have to get rid of water. The problem, yeah, we have a north light, that's good. But what happens if it rains here? Well, we need to create something here to get the water and get rid of it. And this is the weakest point, because if it rains a lot, the water can end up entering here and there will be water leaks. Complicated, but we have to work it out, because that's why architects are here, because we have to do something that is difficult. And we can copy a lot of details. I'm not making up anything from scratch. I'm just copying, because there are guys that have already solved these issues: the thermal insulation, the water collection. Okay, so it's already done, and I will copy one of those details. So we have plenty of them. As you can see, it's always, we have structural elements, and we always have something like this with the thermal insulation above the structural element. If this is the beam, this is a structural element. So we place the thermal insulation above, and we have to protect this element against water. This is what we're going to do. And what kind of material are we going to use? We're going to use a sandwich panel. What is a sandwich panel? Well, we all know what a sandwich is. So a sandwich panel, it's a panel that has different layers. And then we have two layers, and then we have something in the middle, like a sandwich. Okay. What are these layers, and what are the external and internal finish, and what do we have in the middle? Well, in the middle, we always have the rigid insulation. Like this, you see that here we have two layers of wood, and then we have the rigid insulation here. We can do this with other elements. like this one. This is aluminum. So we have the thermal insulation here, the rigid insulation, and aluminum inside and outside. We have this overlapping so that we can connect 2, 3, 4 different panels, but it's always the same idea. And this is quite good because these panels come from the factory and they are cut to the right measurement, and we only have to place one beside each other. And we have waterproof because this is aluminum, so it doesn't, it's not affected by water. We have thermal insulation. We have a nice indoor finish, and they have thought of this joint so that they can get rid of the water that can come through the joint. Okay, so everything is, the manufacturers have already thought about all the issues that we can have in this panel, and they have already solved it. We only have to place those panels on our roof. This is what we are going to use. We can have sandwich panels made of wood, metal, aluminum, or steel, and we can have, this is a cement sandwich panel, but it's the same. We have 2 thin layers of this cement, and then we have the core made of thermal insulation. You will find a lot of examples of these panels, and they are quite cheap, and the construction is, it's quite fast. So I think it's a good option for, and this is, well, this is the thermal insulation and 2 layers like that. This is the roof we are going to use. So first we have to create one of that roof. Well, but first, as you see, well, I don't know if you have the same issue in your drawing, but when we created this beam system, because we did this, well, I cannot select the beam system now, but this beam system, it was mandatory that the truss and this tilted beam, they are meeting at the same point. So that's important, but we don't have the last element here. So I think we can copy one more element. Copy. We need a good reference point. Remove constraint. There. And now there is a beam in this place. We have to do the same with this side as well, because yeah, I don't have the beam here, so we have to copy all these here because we need an element here. Okay, so once we have this, we have the wall here. You have to complete this with walls or curtain walls or whatever you feel like. You have to complete this roof with this kind of roof as well. Okay, and now we're going to work with one of the elements, and then we will copy. That's the good thing of having the same distance between all the columns, because once we are done with one element, then we can copy it many times. Let's use this front or back view, and this is the section. So this is the top chord of the truss. Here we will have the bottom chord of the truss. This is the beam system, and these are the truss, the vertical web and the diagonal web. What do we have to do? If we look at the detail, where is this here? If you look at the detail, I think the other one was better. Yeah, so we have to create a shape like this, and then we have to get the water here. Okay, so we're going to create that roof with that shape. And how can we do that? I think the easiest way is to use a roof by extrusion. Okay. First, we created that roof. In that roof, if you remember, we edit type, and we have the metal deck, the rigid insulation, and the aluminum. In this case, we don't have a metal deck. We don't need it because we are not going to step. We need a metal deck when we are going to step on that deck, because this is a structural element. In this kind of roofs, we just need the rigid insulation and 2 aluminum layers. So I'm going to duplicate. I'm going to create a roof, the sawtooth roof. And I have, well, the move this down and then move this down. So the core boundary will be the rigid insulation. 4 inches. Well, we can have more, but 4 inches is good. And here we will have 1/2 inch. So in total, it's 1/2, 4, and 1/2. So in total, we have 5 inches. Is 5 inches enough? According to the passive house standards, for sure, this is not enough. But anyway, we're going to do this. And if we need more thermal insulation, we can always add more thermal insulation above. So now we have created this. Here we have the sawtooth roof. And I have created the roof by extrusion. And this is very convenient, the roof by extrusion, because I can create this one here. And now I'm going to trace this here. And I'm going to finalize this here. Okay. And probably I would need something else here. Now I'm going to apply an offset of 5 inches because this is the thickness of that roof. And going outwards. Okay. And now I have to delete the original line. Now make sure that you trim this shape. And if everything goes well, I click finish and we do have a roof. Nice. Okay, so you see what I have done. I created this profile, and then I have the same thickness. I know the thickness of the roof, it's 5 inches. So I offset these 5 inches, and when I apply the finish, the roof or the editing mode, I have the right thickness with the right shape. Okay. If we look at the 3D view now, yeah, we have to fix this. We have to make it shorter. And on the 3D view, top view, let's adjust this to that level, to the, let's align this to the wall external face. There you go. I'm not happy with this. Okay, let's, because I want to create this shape, that gutter, with the same roof. So I can always edit profile. And if I edit the profile, I want to go up here. And now I want to go 5 inches. this way, and I want to go up, let's say 1 foot less, 6 inches. And let's see what happens. Yep. I am not, well, yeah, we can do that. Okay, but here we have this element, and we are going to get the water from this. I'm not happy yet, so I will edit this profile, and I'll make it deeper. Yeah, I think that will work better. And shorter, 10 inches. Yep. Okay, so this is the basic roof. This is this cap protects this steel beam here, and here we have created this to get rid of, so with the water will go down, and then we have to get rid of water doing that. Okay. What's next? We can create that gutter. By the way, I told you that first you need to draw different things because otherwise we don't. I have already done this, and I have drawn my own detail. Okay, so now I know what I'm doing because I'm copying, but at the same time I need to draw, because if I don't draw, if I draw, I understand, but if I don't, I'm not able to draw something, I don't understand it. Okay, so first I have drawn this detail in my paper, like an old-fashioned architect, as I am. And now I'm making decisions based on this drawing. So here, this is not, we need something here to protect this against water, because when water falls, it will end up being in this corner. So we need to reinforce this corner against the water. So what can I do now? I can create architecture, component, model in place, and I'm going to create, well, something that it's a roof, because that family belongs to roofs. And I'm going to work with extrusion. I'm going to set this on grid A. I think it's on grid D. And now I'm going to draw this shape like this up to this point. And I'm going to use the offset. 5 is too much. Let's say 2 inches. Yeah, 2 inches work. Like this. And now I have to finish this and this. Now trim. I think everything is closed now. And there you go. We can finish the model, and now we can take it in this direction. Okay, now I have the roof. I have this gutter that it's made of material that is more resistant, probably thicker. So this can be made of galvanized steel or lead or some resistant metallic element that can bear all the water that is coming in this direction. Okay, are we done with this? We can make it better because now look at this. If we don't protect this, we can have some water leak between these two elements. So water is terrible. We have to be careful with water. So what I would do now, I would create like another waterproof layer that can be made of, I'm going to create another roof by extrusion. And I'm going to create a different roof here. I duplicate, and this is waterproof. And this can be made of, I don't need this layer, so I can delete it. The core is going to be not rigid insulation. You remember that we had this EPDM membrane. Okay, let's make it 1/2 inch. And then we can have another aluminum layer here. Yeah, we can have this. I click OK. And now I'm going to protect this. There you go. And I can go up 1 inch. Go up. Okay, why do I have this? Because I need to protect this connection. I don't want the water go between these two elements. So I have a continuous element so that the water ends up here. This is what I want. And now I close this. Oh, no, sorry, I'm working with a roof by extrusion. So what I have to do is the other way around. I have to delete. You can do this with a roof by extrusion, or you can create an architecture component model in place. And the way you have to do things is, well, it's different. If I'm working with the roof by extrusion, I need only just line, and then I apply, and we will have the thickness. If I'm creating the architecture component model in place, then you have to create all the profile, and you have to have a closed line. But I think now it will work. Yeah. Okay. Oh, yeah. And now I need to go on. No. Well, just to make sure, I will align this and this. So I think now this is well protected. We have the sandwich panel with the thermal insulation. And we have this sheet, it's very thin, but it's protecting this against water, or it's an extra protection against water. And then we have the gutter, and the gutter will end up getting rid of the water. What's next? Yeah, we need a window here because we need this northern light, but we need a window. And how can we do that? We can do that with a curtain wall. So I'm going to create a curtain wall going in this direction, and then I will have everything I need. Looking at this, I have the opening with the glass because I have to protect this. Then I have the thermal insulation, I have the waterproof, I have everything. So let's do it. If I open the north elevation, okay. This is the north elevation, and I want to start my curtain wall here at this level. Okay, so I have this protected against water and with thermal insulation. Then I will go up with the curtain wall, and finally I will get to that point. Okay. Okay, but I think I have to define those levels to make things easier. So I'm going to change the scale. Okay, this is level 36. So now I'm going to copy this level here. This is level 38. And what is the, yeah, I need to copy this level again up to that point. And that is level 41 and 6 inches. Okay, so my curtain wall has to go from level 38 to level 41 and 6 inches. Let's do it. And now I have to go to that level, the level, I go to view, plan view, to see, no. Wait. Okay. So this is level 38. And where am I? Yeah, I think, yep. I think this is the roof. No, I'm lost. Okay, never mind. I think I'm working where I'm working. Oh, I'm working with the second one. Yeah, so I have to start level 38. So this is the second one, and I want to start the level here. So I'm going to work with wall storefront. I'll start on level 38, and I will stop this at level 41 feet and 6 inches. No tough offset. And then I will work with the vertical grids and all that stuff. Okay, so I'm going to start here, and I'm going to end there. Okay, so now I have to see what I have done. I don't like it because look at this. This is the vertical elements of this, and I want this vertical element to match this beam system. Remember, we are working with the frame structure. All these points have to be at the same point. So if we have two different bars or two different elements or beams, and we have this distance, it's not working well. So all these should be matching these elements here. How can I do that? Well, first, let me see where I am. Okay, at least the height is the right one. Maybe it's not in the right place, so we can move it. Remove constraint. Move it, remove constraint. No, it doesn't move. Maybe from the north. No. Okay, interesting. I'll fix it from the plan view, maybe. I'll fix it later. But I need to move this outwards. Oh, probably because I need to move everything now. Okay. There you go. Now it works. Yeah, because if I'm selecting only this element, it's pinned and I cannot move this vertical element. I have to move, I have to select the whole wall, the storefront wall, and then I can move it. Now I think it's matching well. And I need to fix the distance between, and I only have to work with, no, I have to select the wall. And you see here that we have vertical grid number 9, but we can't edit this. It is because I have to change the type. And when it comes to the vertical grid, I don't have to use the maximum spacing. I have to use the fixed number. Okay, so when I click here, vertical grid, fixed number, and I apply, now this is editable. And how many of them do I need? The same number I used for the truss. I think it was 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. So if I type here 11, does it work? Yep, apparently it works. And if I look at the level here, yep, now it works perfect. Okay. There you go. We're almost done with this. We're not done with the, because now we have to think how we close this gap here, this triangular gap. It's not easy. And well, there's another thing that we have to take into account. So now this is the gutter. We are getting the water. So we either have a pipe here going down. I'm not a fan of this solution because if I had a pipe here, I would be going with water inside the building. I don't like this option. I'm always copying something. So what am I copying now? I'm copying throw. Okay, I'm copying this. This is a building. I think I've shown you this building before. So by doing this, they solved. So this is not a sawtooth roof. This roof is made of these beams, but they are north oriented, and then they have this like a gutter, and they just expand this out of the wall so that they can get rid of water, and the water is not pouring through the wall because that will cause some issues. So it's this roof is made of these elements. They are connecting. They are connected all together. But by placing this beam, we have a nice effect here. Okay, so this is the internal space. This is a light that we have. It's a northern light, so it doesn't bother people working here. And well, it's a nice building. And at the same time, he creates this effect with lights and shadows. And this is the facade of the building. So it's a concrete wall with those beams, and that's it. And this guy is using the same elements even for overhangs or for everything. This is the architect, the Spanish architect, Fisac. He passed away a few years ago. Yeah, well, that building is amazing because everything is with the same philosophy. So those are the steps. The steps are like this is the overhang. They have the shape that helps bear the load, and they don't have any support here, so they are extended from the wall, and we don't have anything here at this side. So everything is like floating in this building with concrete, and we have these nice views in the step. It's very, I think there was a movement, brutalist architecture. Yeah, so they have this in the 70s or 60s or 70s. There was a movement about this brutalist architecture. And well, they wanted to expose the concrete. Okay, so there are examples of this in different areas. And there's, okay, this is quite famous because this is the Boston municipality. And well, we have this kind of brutalist architecture with exposed reinforced concrete. Well, it was in fashion in the 70s. Now I think it's nobody will accept this because it's it's tough. I mean, it's interesting, but hmm? Well, interesting. Anyway, what I wanted to show you is that I'm going to extend the gutter so that I don't have water pouring on my wall. Well, this is controversial, so I assume that some of you or someone would not want to do this, but I think when it comes to getting rid of water, I think this is the best option. We extend only the gutter. We don't have to extend the whole roof. Well, we can extend the whole roof if you want. Anyway, the good thing is that now we have the roof, we have the waterproof layer, we have the gutter, we have light here, and now we can copy this solution in different, so I'm going to select all these elements, including the curtain wall. Yep, I think this is it. And now I can copy multiple okay, so on and so forth. And now it works because we have the curtain wall here, this roof element, the waterproofing, and everything is working well. Are we done with this? Not yet, because I would do something, yep, something else to protect this against water. And I would use another architecture component model in place. I would use another roof element and extrusion, and I will create a flashing. Okay, what is a flashing? Nope, it's not. Flashing waterproof. not really. Okay, there you go. Well, a flashing is a metallic element that protects something against water. Yeah, something like this. Do we have a flashing somewhere? The roof membrane. Okay, but as you can see, especially corners are quite difficult to protect, and everything is about overlapping things. Okay, so we have this, we overlap this layer, and then we overlap this layer because we have to prevent water from entering the building. But something like this is a flashing. It's like an aluminum element that protects part of a wall or a roof. So I'm going to do this here, and it's just to go out this way. Okay, and now with the offset, it's something very thin, let's say 0.1 inch. It's 0.5. And now I close it. It is closed. Yeah. There you go. Oops. Okay. So as you can see, this is about protecting things against water and overlapping things. So I have the, look at the section. I have the roof. This is the roof. Then I have the gutter. Then I have this element overlapping this. And then finally I have this element overlapping the waterproof layer. Okay, so now I think we are moving the water down and out, down and out, because it goes away out of the building with the gutter. And here, there, okay, yes, I'm going to do this because there's a weak point here between the roof and this curtain wall. So I think if we use this, we edit in place, edit extrusion, and then we use this to protect this connection, will be even better. Okay, so now we don't have a risk. Then we have to seal this for sure, but at least we are moving the water out of this weak connection. We can always make it bigger or longer. Okay, better. It's always about overlapping things so that we don't have corners or elements exposed to water. So this is what we have to. Okay. So there's light, there is thermal insulation, everything is protected against water, and that's it. We're not done because we have to find out what to do here in this triangular element. And but I like this because when we are working with a section, let me work with a section, view, section. Okay. If we are working with the section, all these elements, we don't have to create parts, and everything is a 3D element. So when we're working with a callout, we don't have to do a lot of things with parts or with, we can create parts here. I think we already created, I don't know, we already created the parts, and then we can change the colors, and we can change the patterns, but now everything is 3D. We don't, so we can change the colors, but we don't have to create parts and then extend one of the parts and then the other one, because everything is made in 3D. And when you get the section, it works. Because remember that when we worked with parts, some of the things that you created in the section didn't show up in the 3D model, especially if you are working with regions, the detail lines or regions or detail components. If everything is 3D, when you have the section, everything will be working. We have to fix things here because this connection between this beam and this and the truss, we have to work on that because these are floating. So we have to work with this option of steel meter or coke. Okay, but I will show you this in a different video.